Hi guys, today we're going to continue our lecture in chemistry involving formula or molecular weight. And since we discussed earlier the concept behind this topic, and now we're going to continue solving problems. So that's why we started now in problem number 4 because we just finished solving problem number 1, 2, 3. So in this video, we're going to solve 5 problems. We have problem 4, 5, 6, 7, and 8. Okay, so we believe that by solving these problems, you will be able to understand further about this topic, and it will help you in your chemistry class in solving problems in formula or molecular weight. Okay, so I just gave you an overview on what we are going to study today involving formula or molecular weight. So without further ado, let us jump to our lecture video. Okay, so let's start with problem number 4, in which we need to calculate the mass in grams of one atom of carbon-12. So basically, we have one atom of carbon-12 here, in which we just need to find out what is its weight in grams or its mass in grams. Okay, so to begin, let us first write our given here, in which we have one atom of carbon-12, and then we learned from our previous lecture the Avogadro's number, which states that for every mole, so I will just write here, we have 1 mole of carbon-12, we have 6.02 times 10 to the 23 of carbon-12 atom, right? So we have atom of carbon-12. Okay, so from here you can easily see that the atoms of carbon-12 will be cancelled out because we have 1 in the numerator and 1 in the denominator. Okay, so now we know how many moles of carbon-12 we have, but what we need to find out is its mass. So in order to get that, we also learned this from our previous lesson, that in order to convert mole to mass, we need the molecular weight of carbon-12. Okay, so using the periodic table, we also seen this in our previous lesson, that for every 1 mole of carbon-12, we have 12 grams of carbon-12. Alright, so again, you can see that the number of moles unit here will be cancelled out. Okay, so what's left is the grams of carbon-12. So if we calculate this whole thing, we will end up with a unit of grams of carbon-12, right? So let us use our calculator to answer this one. Okay, so we have 12 divided by 6.02. Okay, so I'm using calculator, so I'm just going to put shift log right here. So I will have here 10 with the power which we need to enter on the parentheses. So I will have here 23. Alright, so I will have 1.99 times 10 to the negative 23. So if you want, you can round this off into 2, but I'll use this one, 1.99. So I will have here 1.99 times 10 to the negative 23 grams of carbon-12. Okay, so this is our final answer for this question. Alright, so now let's go to problem number 5. So in problem number 5, we have to calculate the volume in cubic centimeters occupied by 3.5 times 10 to the 26 atoms of aluminum if the density of aluminum is 2.7 grams per cubic centimeters. Alright, so in our given, we have 3.5 times 10 to the 26 atoms of aluminum. And we are also given the density of aluminum, which is 2.7 grams per cubic centimeter. Okay, so I use the symbol rho in here because in chemistry this represents the density of our subject. Okay, so our requirement is to find the volume of aluminum, okay, in cubic centimeters. Okay, right, so how are we going to do that? First, let us use this one. We have our given, so let's write that here. 3.5 times 10 to the 26 atoms of aluminum. So again, we'll use the Avogadro's number. So we have 6.02 times 10 to the 23 atoms of aluminum, and this will be equal to 1 mole of aluminum. Okay, so since we need to find out the volume of our aluminum here, that means we need to find the mass of our aluminum in order to use the density and find out our volume. So I'm going to show you that here. First, you can see from our calculations here that the atoms of aluminum will be cancelled out. Okay, so that means what's left here is number of moles of aluminum. So we're going to convert this into mass or to weight in order to have this value cancelled out later on. So we'll have, okay, we need to use the molecular weight of aluminum. So for every 1 mole of aluminum, using the periodic table, you will find the atomic weight of the aluminum, which is equal to 27 grams of aluminum. Okay, so in this case, you will see that the number of moles of aluminum will be cancelled out. All right, so now we have the mass of aluminum, but we need to find the volume. So we can use the density of aluminum in order to find out the volume. Okay, so let us proceed here. So we're going to multiply this to the density, in which for every 2.7 grams of aluminum, we have 1 cubic centimeter of aluminum. Okay, so this is the density of aluminum. So as you can see, the grams of aluminum will be cancelled out. So we will be left with 1 cubic centimeter of aluminum. Okay, so we will write our answer here later on. So I'll just write this in white. Okay, so let us use our calculator. Okay, so we have 3.5 exponent of 26, and I'm going to divide that with the Avogadro's number. So divided by 6.02 and times 10 to the 23. All right, then I'm going to multiply this to 27. Okay, so as you can see here, so times 27, and then I'm going to divide it by 2.7. All right, so our answer here will be 5,813.95 cubic centimeters, okay, of aluminum. So this is our final answer in here. All right, so now let's go to problem number 6. If 25 grams of a compound contains 0.42 mole, what is the formula weight of the compound? All right, so this shouldn't be really difficult because we know that the formula weight has a unit of grams per mole, right? So in our given here, we already have the mass in gram and the number of moles. So we can easily get the formula weight just by dividing the numbers. So we'll have here 25 grams divided by 0.42 mole. All right, so what should be our answer here? Let us use our calculator. So we have 25 divided by 0.42. So we have 59.2 52 grams per mole. Or sometimes this is also expressed as 59.52 atomic mass unit. Okay, and we have learned that before in our previous lesson. Okay, so this is our final answer for this problem. So now let's go to problem number 7. So if 4.2 times 10 to the 20 atoms of an element have a mass of 55.2 milligram, what is the atomic weight of the element? Alright, so we have to understand from this given that for our given element, we have 4.2 times 10 to the 20 atoms, which is having a mass of 55.2 milligrams. So these are our given here. We have 55.2 milligrams. So this is our given. For every 4.2 times 10 to the 20 atoms, we have 55.2 milligrams. So we can say that these are equal. All right, and we need to find out what is the atomic weight of the element. So that means we also need to express this in terms of grams per mole. So as you can see, if we want to express this into grams per mole, so our weight or our mass will be in the numerator. So let us write that now. Here we have 55.2 milligram of our element for every 4.2 times 10 to the 20 atom. Okay, so we need this to be in grams because we want to express this in grams per mole. So let us convert this milligram into gram. So for every 1 gram, okay, so let me write that properly. For every 1 gram, we have 1000 milligram, right? So in this case, our unit for milligram will be cancelled out. Okay, so next is we need to get the number of mole in our denominator. So we need to convert our atom into number of moles. So we will use again the Avogadro's number. We know that as per the Avogadro's number, we have 6.02 times 10 to the 23 atom for every 1 mole. Okay, and as you can see again, the atom will be cancelled out. Okay, so what will be left here is in our numerator will be in gram and our denominator will be mole. So that is exactly what we need here. So we just need to proceed with our computation. Okay, so we have 55.2, then we'll divide that to 4.2 times 10 to the 20, and then I'm going to divide that again to 1000 here, divide it to 1000, and then I'm going to multiply that to the Avogadro's number, so times 6.02 times 10 to the 23. Alright, so we have here 79.12. So this is our answer here. We have 79.12 grams per mole. Okay, so this is our final answer for this question. Alright, so now let's go to our last question here. Calculate the mass in kilograms of 3.25 millimole of water. Okay, so we need to express our mass in kilograms. So we have to take note that the requirement is kilogram and our given is millimole. So I'm going to show you why it is important to take note when doing this calculation. So let us use our given here, which is 3.25 millimole of water. We need to convert this into mole. Okay, so we're going to multiply this for every 1 mole of water. We have 1000 millimole. of water. So you know that milli means thousands, right? And we learned that from the units in dimension topic that we had earlier. Okay, so the unit for millimole of water will be cancelled out. So we now have here the moles of water. We need to convert this now into the weight, right? So we know that for water, so let us write that here. So for water, what is the formula weight of water? So we have for hydrogen, we have 1, but we have 2 hydrogen here, so we're going to multiply that by 2. Plus for oxygen, we have 16. So the formula weight for water will be 16 plus 2 will be 18 grams per mole. Right? So we're going to use that here to convert the number of mole of water into grams of water. So for every 1 mole of water, we have 18 grams of water. So again, you can see that our moles of water will be cancelled out. So what's left here is the 18 grams of water in our numerator. However, what we need to find out is the mass of water in terms of kilograms. So that means we need to convert these 18 grams of water into kilograms. So we're just going to convert this, and we know that for every 1 kilogram, we have 1,000 grams. Okay, so in this case again, as you can see, the grams of water will be cancelled out, and what's left is the kilogram of water in our numerator. So now we're going to use our calculator to answer this problem. Okay. All right. So first we have 3.25. Then we're going to divide that to 1,000. And then I'm going to multiply that to 18. And then finally, I need again to divide that to 1,000. So now I have 5.85 times 10 to the negative 5 kilogram of water. So we have 5.85 times 10 to the, what is it again? Negative 5. Yeah, negative 5 kilogram of water. And this is our final answer for this problem. So I hope that you learned a lot from the sample problems, and it helps you in your studies in chemistry involving formula or molecular weight. All right, so thank you very much for watching our video, and we're going to post more chemistry problem solvings in the future. So please like and share our channel. Thank you very much and have a nice day.